Hello, this is David Stokes from Convalido Consulting again, and in this video I'm going to provide some supplementary information with a little bit more detail of the types of data operation we can document using the Convalido data lifecycle modelling diagram. So I've actually prepared a picture here using the tool itself, which gives us an overview of the symbols we can use. As I said previously, there are 37 of those. Each of these corresponds to a different stencil. So if we look in the top left here where it says acquisition, this corresponds in this first column to the symbols available in the data acquisition stencil. If we look at storage, for instance, and if we look at our storage stencil, you can see we have 9 symbols associated with data storage operations. So if we give ourselves a little bit more real estate on the screen, we can look at these and talk about them very briefly. First thing to highlight, as we've said previously, is that each of these operations can act upon either a single item of data, which has no metadata associated with it. It can operate upon multiple items of data, which again has no metadata associated with it. It can operate on a single item of data, which has associated metadata, or multiple items of data, which again has metadata associated with it. And there are shape symbols for each of these different operations and each of these different data classes. So if we talk about these in a little bit more detail, the first thing to talk about is actually how we get hold of our data. And essentially there are two options. There's data acquisition. Data acquisition is an automated process. So typically we're talking about some sort of instrumentation, process control system, or a laboratory instrument where the acquisition of the data is automated. There is typically some sort of conversion from a physical parameter through some sort of transducer into an electrical signal, which will then be further processed to give us our data. That's the automated data acquisition process, and depending upon the instrument or system involved, again that may be single or multiple data items with or without metadata. The next option, of course, is data entry. Data entry infers entry of the data and or the metadata via a system user or operator, and again that can be a single piece of data, multiple items of data with or without metadata. That can be achieved through the traditional screen and keyboard, but increasingly through a tablet device, mobile computing device. It may even be through some sort of simplified keypad on an instrument panel. Once data has been acquired, it can then be stored, and we have options for temporary and permanent storage. And it's important that we understand the difference between the two. So for temporary storage, very often data will be stored perhaps in volatile memory. It may be stored on a temporary basis until it's overwritten or until it's deleted in a controlled and authorized manner. Permanent data is something obviously we're going to rely upon for regulatory reasons for our most critical data, and the reason why we have the bold border for these symbols is to draw our attention to these, because it's the permanent storage of data where we have the greatest risks to our data integrity. But that's not to say that temporary data storage doesn't also have risks, because if somebody can get unauthorized access to a temporary copy of the data before it's stored permanently, and if they change that or falsify that, there's obviously a data integrity risk there. But we need to understand how long we intend to store the data for, where it's stored, whether it's volatile or non-volatile, and so on. So we differentiate between temporary and permanent storage, and under permanent storage we also have the specific electronic record, and as we can see, that is multi-data with metadata. Typically an electronic record contains multiple items of data, and it has to have metadata associated with it, such as an audit trail, and it may also include metadata associated with any electronic signature that's supplied. Once data is stored, there's various things we can do with it. First of all is edit. Again, editing is done by an operator or a user of the system. This should again be on a controlled and authorized basis. Any unauthorized editing can lead to falsification, so there are specific risks associated with the data editing process. We can also process our data. Again, this is done systematically. It's done by software, and there are risks to our data integrity if, for instance, code is badly written and it overwrites data, or it writes the wrong value, or it corrupts data or doesn't store it. And the way we mitigate data processing risks are through validating the software. That's a very common way of mitigating data processing risks. We can then copy data, and in most cases, in most systems, and in most life cycles, we'll have multiple copies of the same item of data, possibly at different locations within the same system, used for different purposes. Very often data will be copied or moved from one system to another system, and different copies of that data may have different risk associated with it. So one copy of the data in one system may be used for regulatory purposes, may be high risk. In another system, that same item of data might be used for purposes of calculating process efficiency, for instance, so it has a much lower risk. And we need to understand how different copies of our data are used, why they're used, the risks associated with those copies, and also how we need to restrict access to those different copies of data. We can, of course, delete data. That should be on a controlled and authorized basis. Any unauthorized deletion of data is again a risk, so we need to think about the risks associated with that. Again, there may be risks with deleting the wrong data, for instance, so validation of software around data deletion is important, as well as permissions and who's authorized to perform any deletions. And finally, we have a move operation, and as you can see from the symbol, the move operation is basically a combination of a copy and a deletion. So essentially, when we move data, we copy it from the original location or the original system to the new location or the new system, and then we delete the original copy. Again, if this goes wrong, we may copy the wrong data. We could delete the data before we copy it. There are a number of risks that we need to associate with that. So it doesn't matter how complex our data life cycle is, or how we think about the functional operations that are taking place. Most of the data life cycle, or all of the data life cycle operations, can be defined by using data acquisition or entry, data storage, editing, processing, copying, deletion, or moves. And certainly our experience is that for any life cycle we've been modelling, a combination of these operations working on single or multiple data items with or without metadata allows us to describe every data life cycle that we've needed.